let's see how this applies to trig functions. So here I've got the graph of the sine of x, and you can see that this doesn't have an inverse, right? Because it fails the horizontal line test. For example, if I tried to figure out what is the arc sine of x, what I'm trying to do, remember sine is the name of a function, and it starts with an angle, and it gives you a number. So the inverse sine would do the reverse process, right? It would give you some number. You start with some number between -1 and 1, since this output's always between -1 and 1. To do the inverse, you'd have to start with a number between -1 and 1 and get back the original angle. So for example, if I asked you for the arc sine of 1/2, what I'm really asking is what angle has a sine that is 1/2. Well, from the graph of the original sine function, you could go, okay, here's the output of 1/2. What angle is it? Well, here's one answer. Pi 6, right? But then because this fails the horizontal line test, there's another answer. This one's 5 pi 6. And you can see there's actually infinitely more, right? Because it's a periodic function. You can always keep going and find more and more and more. In this case, either to the left or to the right. So there are several answers here. Well, infinitely many, really. So you can have pi 6 plus any multiple of 2 pi. Since sine is a 2 pi periodic function, you could add any integer multiple of 2 pi, and that would give you an answer, right? And so there's all of those on the upside here, but then there's also these on the back side of the mountain here. So 5 pi 6 plus 2 pi times any integer. I guess I could use n again, or just use another number k, where these are just nice round numbers. You could multiply by 2 pi. So, alright, infinite many solutions there. Well, the problem is that this function is doubling back on itself, right? And so we know the solution is to cut the function off, and how we cut it off is up to us. So let's go and look at the graph of sine again and see what would be a natural way to cut it off so that it does have an inverse. So we stick around 0, we'll be able to work with the smallest angles, right? There's no reason to be working with angles like 7 pi way out over here. We might as well work around 0. How far can we go from 0 before this function starts to double back on itself? Well, you can see you could go as far as half pi this direction, and you could go as far back as negative half a pi, right? Negative pi halves in that direction, and then the function would have an inverse. So I just cut off all but this part, and so get rid of this part over here and this part over there. Now it has a nice inverse. So now that's just one choice. Sometimes we call that the principal branch of the inverse. This is the choice that's made, like for most calculators. If you use the inverse sine key, it's going to give you an angle between minus pi halves or pi halves. Unless you're in degree mode, of course, then it'll just give you an angle between minus 90 and 90. So be careful about what mode your calculator's in. That's the principal branch of the inverse sine. So when we see the inverse sine of x, so that means an angle, right? Because sine takes an angle, gives a number. The inverse sine will take a number and give us an angle. So it means a particular angle. It means the angle between minus pi halves and pi halves, whose sine is that given number x. Let's look at an example. Somebody says, well, what's the arc sine of 1/2? We said that there are many, many angles whose sine is 1/2, but there's only one that's between minus pi halves and pi halves. It's this one right here, right, which is pi 6. So we know the arc sine of 1/2 is just this specific angle oh my goodness, I wrote pi 6. Pi halves, I meant pi 6. Okay. Right? Pi 6 is the angle whose sine is 1/2. At least it's the only angle between minus pi halves and pi halves whose sine is pi 6. Okay, so the trickiest thing about these inverse trig functions is just knowing, okay, there are many, many angles that have this particular sign. Which angle do you choose? So by narrowing it down, by cutting off the domain of sine in order to get an inverse, then that just narrows down the range of the inverse sign. Now, there are actually two ways that this is written. The other way it's written is as the arc sine. So if you see arc sine or hear someone say arc sine, then that's another, oh, with no -1 there. Okay, that's another way of writing it. Right? So the sine takes an angle and gives you a number. The arc sine takes a number and gives you back an arc, right? A particular angle that you started with. So that's another notation that's used. You know, the nice thing about saying arc sine is it avoids a little bit of confusion, because remember we said that if you see sine squared of x, what that means is sine of x squared, right? Or sine of x times itself. But this, that -1 on the name, is special, and you get into trouble. This does not mean sine of x to the -1, because sine of x to the -1 is 1 over the sine x, and of course the sine 1 over the sine is the cosecant of x. The cosecant of x takes an angle and gives a number, but the arc sine, this -1, is the -1 we use on the name of a function in order to indicate that it's an inverse. So the arc sine can't be the cosecant, because the arc sine has to give out an angle, and the cosecant doesn't give out an angle, it gives out a number, 1 over the sine. Okay, so just watch out for that confusion. If you understand that this -1 on the name of a function always means find the inverse function, then you'll be safe, right? So just avoid that. But the reason that students get confused is because a lot of times we end up squaring a sine or a cosine or taking them to higher powers, and it's just convenient to name that function, the trig function, to some power. Just watch out for this one, so you'll figure it out in the end.